Okay, so good afternoon to everyone. Today we will begin with another topic.
Good afternoon, sir.
Right, good afternoon. Another topic on operating systems. Databases, to some extent, we have done it. I'm just giving you time to prepare along those lines. If required, we will again review once again, like after you go through at least a certain material. That's the idea behind. Java also, to some extent, we have covered. So that I request all of you to make an effort and see that you learn whatever best that you can on your own. And then we will open classes on all the topics so that we can actually cover the gaps or the doubts, whatever that all of you have it. That is the idea behind going through these things. So, computer science means at the core level, you have maybe you can say four different important subjects. One is the computer itself, which you try to learn through computer organization. So, how the different modules or the parts of a computer are integrated together to give you the what it is programming facilities. That is one part of it. We have not discussed much on that particular issue, except for how the internal representation for various data types are represented. That is a part of the, we can say, computer organization to some extent. And the second subject we can say is operating systems. It is very important subject, no doubt. And all of you know very well that the hardware that constitute a computer cannot be used on its own without the operating system. So hardware on its own, yes, you have all the devices that are physically connected in some form or the other using some like various standard bus architectures and all that. But you cannot use it unless we load the operating system. So it is the software that is making all the systems to be available to the end users of the machine. It is the operating system that is making all the end users to use the various hardware devices. Right. So that part we will be talking about how what an operating system is, what are the various modules, how are you going to implement or design or develop the operating system, that kind of things in a what it is, a level where you can understand, but you can't build an operating system with this particular discussion. But at least you will know what are the functions of an operating system, what it is made up of, and how we can use, and so on. Right? So that is the one part of it. This third subject is database management systems, especially when you want to do the projects and all that, where a lot of data is involved as a part of implementing a project. So we require some mechanism to store and retrieve data more efficiently. And that's where the database systems will help you. And MySQL is one among them. We have learned to some extent about how to create databases, how to create tables within them, how to integrate them, how to query, all that part of it. So I request all of you to go through the W3 schools and complete everything that we talked in the last class. And then the programming part, right? Programming also, at least one language if you are good at, then you can learn on your own other languages as well. So one should learn one language thoroughly so that what can be done like from a language, how a project or small programs can be developed. That kind of thought process, right? So essentially, you need to develop that kind of thinking in the mind about how to approach, given a problem, how are you going to solve it? So in that context, we have learned Java language to some extent. where what is important with respect to any language is that you should be thorough in terms of reading the data and ultimately presenting the output onto the screen or onto a file or whatever. So input and output, you should be comfortable while using any language thoroughly. All different ways of reading the data and different ways of displaying the results or storing the data results onto the file, that kind of stuff, because that is common for all the programs. So what will vary from program to program is only the logic or the actual solution part. But reading and writing part is going to be required for every program. What it means is you must invest reasonable time in learning about how to actually read the data and how to present the final results. So that is the direction in which we have learned so far. Right? By using command line arguments, you can get the data. By reading through standard input in the form of system.in or whatever, you should be able to read it. You should be able to convert from values from one data type to another data type. More so from you should be able to convert from a string into different data types, or you should be able to convert from different data types back into a string format. You take any language, these things are very, very important. You need to learn. So with respect to Java, we have done that. So by any chance you get a project in some other language, first your focus must be on these aspects, so that you can start developing the project very quickly as a part of it. And then you have the control structures, iterations, recursion, all those related aspects. This is a bigger picture about foundations of computer science, how important it is. That's the reason why we are actually studying, and this course is common to all the 4 branches. Okay, so coming back now, like what it is, the operating system, right? So we need to first understand what it is. So whenever you talk about anything, what it is, there will be different aspects, right? There may be either a simple single definition, or you may have to actually explain it by talking about what it can do, what it cannot do, that kind of mechanism. So most of you might have already studied this particular thing. And there may be some common definitions, but you should not just simply what it is by heart those common definitions, just simply say without even understanding what they really mean. That's not what we are expecting from all of you. So in some of the what I call textbook, probably you say that an operating system is nothing but a resource manager. What are the important resources that the operating systems manage? So very important resources naturally are the very most important resource that you actually talk about is the central processing unit, right? CPU, or we can say processor, right? Processor is the other term that we can actually talk about. This is one of the important resource, That's why there will be a whole lot of discussion on how are you going to manage the central processing unit as a part of your study as well as a part of your implementation of the operating system. So what are the other resources that your computer constitute? The next important resource that any computer will have is memory. So naturally you have to manage the memory. Memory constitutes the main memory. You are actually talking about the main memory or the primary memory, right? So this constitutes the second resource that need to be managed. And then the third resource that any computer system may have is maybe the secondary storage, right? In the form of disks and all those related stuff. Secondary storage. This is also a very important device, we can say, or device management, right? So that's why indirectly sometimes we also call operating system is going to manage various devices. Secondary storage. Secondary storage is basically the basic difference between main memory and secondary storage is one is permanent, like in the sense that once you store the information, it's going to be there even when you switch off the computer system. The other one is only as long as the power is available, the data that is stored in the memory is going to be there. And the moment the power supply is gone, the data is gone there, right? Persistence, right? We use the term called persistence. Persistence means if a memory is persistent, meaning that the data is going to be there even when the system is switched off. So secondary storage is persistent in nature, main memory is transient in nature. So only temporary in nature. So that is going to this thing. Secondary storage, the data mostly constitutes the basic units of data here is going to be in terms of normally blocks or sectors. So these are the terms that we normally use, sectors or blocks. Basic units of data. Whereas in the main memory, the basic units of data is going to be individual bytes, or sometimes maybe we can also call them as the words is another possible listing. So at a byte level, it is possible for you to control in the main memory, whereas at a sector level, right, it's possible to control the data in the secondary storage. So one sector may constitute sometimes 512 bytes or 1024 bytes and so on. So whenever you want to modify any particular byte or any particular data within a file and so on, you cannot modify the individual byte or individual data. No doubt, ultimately, only that is going to be changed. But the question is, you have to first identify what is the sector or the block that contains that particular data that requires modification. So first read that entire sector or block into the memory, and then modify that part of what it is, data, whatever requires the modification. And again, you have to write that entire block or sector. Similarly, in the main memory also, even if you want to make any changes at a bit level, you cannot do that. So you have to read the entire byte that contain many bits, and then make any changes that you require on an individual bit, and then again write back the corresponding byte. So there are certain basic level, the minimum amount of data that the corresponding managers can actually operate, right? So you need to understand those things. So sectors are the basic unit, bytes are the basic units of the main memory, and here are the secondary storage. That is why, in fact, some of the operating systems, those things are named. In fact, secondary storage is such an important thing, and you cannot use the entire disk, right, as one entity. That's why you require something called file systems, right? So we use something called file system. You have to build a file system on top of your secondary storage, maybe a disk. So one disk can constitute so many sectors and blocks, but you are not directly given any control on the sectors and blocks. But operating system will contain one of the important system called as file system, through which OS will provide the services for creating folders or directories, or storing or creating files within the directories. So whatever information that you want to store, only you are going to talk about. So it is the operating system that will decide which blocks or sectors are to be allocated for that particular file and store this information what the user is asking for. So a lot of services are provided by the operating system by way of resource management. So earlier days, in fact, there used to be another important storage. Maybe you can call it as tertiary storage. See, the secondary storage you can think of as if they are all magnetic disks or the kind of diskettes like that are actually stored permanently inside your system. Sometimes even that is not good enough. You want to take backups of your data so that the organization should run smoothly even when the entire computer fails for some reason. You should be able to again start from what it is from the failure back into that. So all that is possible only when you maintain backups of the data. And backups are going to be normally stored on the external storage devices, which are normally called as tertiary storages. So earlier it used to be tapes, magnetic tapes. But now also you have external hard disks, right? Now also you have external disks. So how are you going to manage? Like your computer should be able to provide some kind of services for copying the data from the secondary storage into tertiary or external disk, or from there back into the back into the secondary storage. This is one way of looking at operating system as a resource manager. But then normally I actually talk about give a different definition for that particular thing, and which let us call an operating system as a service provider. Let us call this as a service provider. So an operating system, whenever you you are trying to use it, it is providing various services. Services by which you can use the resources. So there will be a number of services using which you are going to make use of the corresponding resources or devices of a computer system. So that's the reason why in the earlier operating systems, there used to be something called SVC, service calls, right? Service calls, meaning that SVC stands for that. So, in other words, strictly speaking, you are given an opportunity to develop an operating system. Let us say, all of you know that it is a software. Operating system is a software unit, no doubt about it. Whenever it is a software, that means it is basically a program. If it is a program, then you have to select one language for developing that particular program, and then learn that and start writing the code corresponding to that. For example, Linux operating system or the Unix is actually developed by using the C language. So all of you are already familiar with C language. Now, if you are given the task of writing the software, writing the operating system code in C language, how are you going to do that? What is your starting point? Right? Already main function is there, no doubt. But what are the other things that you may have to develop that? So there must be clarity in writing the software, writing the operating system from the definition of the operating system. Then it becomes more understandable and all that. Resource manager, all that theory, yes, no doubt. You are going to talk about a lot like a CPU manager or short-term scheduler. So there is something called schedulers, normally you call them. So management of the CPU is done by using scheduling concepts. Anyhow, so now coming back to this service provider here, SVC stands for service calls. So is the old term, in fact, with respect to the earlier operating systems, which are used to be mainframe systems. Right? For mainframe, they used to call it as service calls, SVC. Whereas in the modern operating systems, like maybe your Unix, Linux, or Windows, or whatever, we normally use the term called system calls. Any operating system is going to have a number of system calls implemented within the operating system. And system call is a way by which you can request the operating system to provide a service. right, is a way to request operating system to provide a service. Service may be like to get access to a particular file, or to create another process so that you want to run that particular process and so on. So system calls like operating system now can be considered as a service provider, or in other words, you can say that indirectly an operating system has a collection of system calls. A number of system calls are going to be implemented in order to get access to various devices that are there as a part of the operating system. As a part of the operating system. So what are the system calls here? Some of the system calls, because as you said, Unix or Linux is developed by using C language. The system calls will have syntax similar to a function, because ultimately when you are doing all that, the C language, whenever you write any C program, is considered as a collection of functions. A program may contain a number of functions that are implemented as a part of it, out of which there may be one main function, which is going to be the starting point of running that particular program. And from there, other functions can be called here and there and all that. So a number of functions in C language must have been developed, and those functions are called as system calls in operating system. So some of the signatures of the system calls, like, for example, with respect to the file system. So file related system calls, what are they? What do you want to do with respect to a file? You want to normally open a file, right? So you want to open a file. So open is one system call. This is only the name of the function or name of the system call. But the moment you talk about a function or system call, every function or system call must return a value of a particular data type. And the function may require certain parameters. Those parameters are specified with some specific data types, and all those related stuff will come along with that. So open is an important system call. And after opening, most of the time, you feel like reading something from a particular device. So read is another system call as a part of the operating system. And then you have write is another system call that is there as a part of the operating system. And sometimes, like as a part of the operating system, so you have opened it, but you don't want to read data continuously from the beginning till the end, but somewhere in the middle. Imagine a situation where you have stored details about a number of students. Student records are there. You want to somehow like read data about a specific student. So given the student ID, like you want to identify where it is likely to be within the file, and then move to that particular location without actually reading all the previous things, whatever are there. So to move to another known location, you require another system call, like maybe either in terms of seek is a system call meant for that. Seek is a system call by which you can move the file pointer from one location to another location without actually reading the data in between. Whenever you read the data, even then file pointer will move. The location of a file pointer will move to another location. But without doing that, you want to go to a specific location, you can always do that. So there is another system call meant for that. So you want to find out where you are currently within the file system. So for that, there is another system call called tell. Tell me where my file pointer is within this particular file. And after usage of all these things, you want to give the resource back to the operating system, because all these things are the resources. And there is always a what it is, only certain number of resources can be given to any program that is running. So there are limits. There are limits on the number of resources that can be allocated to a particular what you call process. So whenever you have completely utilized it and you want to give it back, there is another system call meant for that, which is called as close. Close the corresponding file or whatever. So these are some of the system calls related to file management. File management. If you really want to see the signature of these things, normally signature of, for example, open system call is going to be int followed by open, and then bracket. So to the open, now you'll have to specify what is the file name that you would like to open it. That means it's going to be file name is, it's a pointer, right? Like pointer to characters as such. So you'll have to specify character pointer or character array, whatever, starting address of that particular thing. So this is the name, file name. So you want to open a specific file name, so the parameter is requirement for that. Because all these things is in C language, that's why you are talking about this particular signature. And the second parameter for that is, how do you want to open this particular file or resource? Do you want to open this file for reading purpose? Or do you want to open this file for writing purpose? Or sometimes you want to open this for both read as well as write. So that kind of thing you'll have to specify, and that you normally call it as mode. So this is the likely signature of the open system call. This is the likely signature of the open system call. And open, whenever it is successful in opening that particular file or whatever, it returns an integer. And remember, all the system calls, most of the times, whenever they fail to provide a service, when you request for any service, either the service might be granted or sometimes it may fail to provide a service. And whenever they provide the service, a certain return value will be there. And it is a normal practice that system calls will return -1 when they fail. When they fail to provide the service. When they fail to provide the service. So one possible failure is, as you can see, you want to open a file for reading purpose, right? And you are specifying a file name so that there is no such file. There is no such file on the system, and you are asking it to open it. So naturally it cannot, right? It will fail. It will search for that particular file name, not there, and ultimately it returns -1, indicating that it has failed. So whenever you write programs by making use of system calls, that means whenever you develop programs making use of system calls, such programs normally you call them as system programs. System programming means that you are trying to use the system calls of the operating system and then developing programs so that the users can make use of it. So some of the standard system programs are naturally, for example, you take Linux platform. So most of the basic commands, whatever, for example, you want to copy a file, right? It is a system program. It is provided as a part of the operating system. There are so many programs. You see, system calls cannot directly be used by the users, right? They can be used while writing the programs. But system programs can be directly used by running them. So the moment you say CP and then a file name 1 and file name 2, So CP is a system program. Internally, it uses the system calls to open the files for reading, open the file for writing, read the data, write it onto that, all that kind of internal details it's going to be there. Similarly, cat is there, by which you can actually open a file for reading purpose and then display it. Cat is a short name of the concatenation actually. So cat can concatenate a number of files and display all of them at once. That's why it is called as cat.
Sir, Linux commands, right?
Right, very much. So these are the commands that come along with the operating system. Right, so they're actually provided so that the user can start using the system. So on top of it, anything other than that you require, you are going to write the programs for whatever purpose and all that. So these are the system programs. So these system programs internally make use of system calls. Simple ideas, right? So there is hardly anything. Only thing is you need to properly understand the foundation or the basics. And then you will be so comfortable in looking at anything for that matter. For example, ls is there, using which you are going to list all the files, whatever are there. So not only like in Linux, in fact, even in Windows also, you have these system calls related. So Windows is actually developed not in a this particular C language kind of thing, but in a it is even more modern kind of it. So the Microsoft has got a number of programming platforms. So they make use of those things. So maybe C# is there and all that. So it is more like object-oriented kind of thing nowadays. The Windows 10 and all that is actually developed. So these are the system programs you need to understand. There are many more like that. So you can continuously give a big list of all these things. But try to understand what is a system call and what is a system program and what is an operating system. These are the various things that you need to slowly get used to. Any questions so far? Okay, so if no questions are there, then we can slowly move on to other topics as well. As a part of this, the actual textbook prescribed for this operating system says you have operating system concept by Silver Sash. Standard textbook is there. You should be able to read that. The first two chapters of that particular book. First two chapters of that book you can actually go through. Okay, so just now what we have learned so far then is an operating system is considered as a collection of system calls. And remember, coming back to this particular thing, right? So what it means is, if you take a look into open, read, write, seek, tell, close, and all that, operating system will make the users to think in a device independent manner. So that is one of the important device independent. That means one should be able to think in a more general manner. So we should not worry about are you using a tape, or are you using a disk, are you using a keyboard, whatever. What all that we say is that all the devices are going to be either input in nature, they are likely to provide the data in the from the input kind of thing, or it might be an output device. The device can be either an input device, output device, or sometimes maybe input as well as output device. These are the combinations. So whenever you say input device, meaning that, so we'll just simply say read from that input device. So the end user is going to always utilize an appropriate thing. And depending upon the device name or whatever, the system will take care of how to read the data from there. You don't have to worry about, are you reading from the keyboard, then do this. Is it a hard disk, then do this, that kind of stuff. So there will be only a fixed set of system calls, very minimal set of system calls, using which you want to read the data or write the data onto input-output devices. That is brought by way of these system calls, in fact. By specifying the device name, that itself will take care of. The operating system understand, because you are supplying the name, device name, or the file name. So that means all the devices are given certain file names, in fact. Right? Devices are attached to certain file. So the operating system understands the moment you specify a file name, in case it is mapped to any specific device, that means if you want to read a device, you need to know what is the corresponding file name. Right? By just simply knowing what is the device file name, so it becomes so easy. Read from that particular device is equivalent to read from that particular file name. You want to write something onto your device, first find out what is the corresponding device file name, and simply write onto that file is equivalent to writing onto that particular device. That is why in the Linux operating system, all the devices are named, and those file names are actually kept in a special directory called /dev. In the root directory, there is a folder called dev folder, device folder. In that directory, you will find all the file names, and all those file names are mapped to various input-output devices of the operating of the computer system. So reading a file is equivalent to reading the data from that particular device. So device independence is coming because of the mapping between devices and file names. And that brings you a lot of simplicity for the end users. Okay. And it is up to the users. Like that means this read system call, whatever that you say, is overloaded, in fact, strictly speaking. Why are you calling this as overloaded? So reading a keyboard is different from reading data from a hard disk, is different from reading data from a USB device, is different from reading data from a camera that is attached to the computer system. Right? So whereas the system call may be the same, but by specifying the file corresponding to that, it's going to invoke an appropriate read. An appropriate read is going to be taking place. So that is how the system device independence is actually provided to the end users there and all that. So that means, as we said, for different devices, you have different read implementations as a part of the operating system. So in other words, whenever people are you are buying a computer system, so along with that, you know the configuration of the computer system, what are the various devices that are like made up of to build a computer system. Naturally, for all the parts, whatever are attached, corresponding read, write, functions must be there. System calls must be there as a part of the operating system. No doubt about it. No issue. So because you already know what are the devices connected, you just simply build the operating system so that all those devices can be read as well as written to, and you provide that and supply, give it to the end user. No issue up to that. But how are you going to actually take care of a scenario where the user want to add another device later on, right? You want to add another device. So at the time of what it is supplying that, you don't have the corresponding, maybe the device is not there, or you have not asked for, or totally it is a new device that has come into the market out of R&D. So you have purchased the new device, no doubt, and you have also connected that, depending upon what is the bus using which it can be connected, or using the USB or whatever. Now the operating system has no idea about how to read the data from this particular new device, because the corresponding read or write code is not there within the operating system. So even though it is physically connected, you cannot use it. So that's where the device driver is going to come into the picture, right? All of you must have heard of something called device drivers. Device driver, all of you know that it is another software basically. So it is a software constituting system call implementations of that particular device, about how to read the data from that device, how to write the data onto that particular device. The corresponding entire program, all those instructions, all those corresponding system call implementations will be there as a part of the device driver software. And as you know now, like all these things, whatever you are actually developing, they are a part of the operating system. So from one operating system to another operating system, it will be totally different. System calls of one operating system may be different from system calls of another operating system, depending upon how they want to implement and all that. So device drivers also then, whenever you are actually connecting that new device, you require the device driver for that particular operating system. So if there is another operating system that you are actually using, you also require a separate device driver for the other operating system also. So there is something called installing the device driver, right? So what do you mean by that? They are likely to provide some kind of disk within which the device driver software may be available. And when you ask the operating system to install this, what it is doing, it is actually making this software also to be a part of the operating system. It is going to become or integrated into the operating system, so that how to read and write data from that particular new device also will be there as a part of the new operating system. Your operating system is getting extended with the capabilities of reading and writing the data on that particular new device that is likely to be connected. That's what you really mean by device driver means. So they are likely to implement both open system call will be implemented on that particular device, how to open it. Similarly, how to read, how to write, and all other connected things. So once you install it, most of the times, what people will do is they will ask you to restart the system, because so right now, whatever is the operating system that you are currently using, before installation of that, it has only the system calls related to the old operating system, without the new device related. Now that when you are installing, what it will do is, it will only install all these things or make changes to the operating system code that is there on the secondary storage, not on the main memory. See, all of you need to understand that your operating system code will be available on the secondary storage, not on the main memory, because main memory cannot retain it. So secondary storage only will contain the actual operating system code, that entire thing. So the moment you switch on the computer system, there is something called booting, you call it, right? Booting your computer system, booting the operating system. So it is a two-step process most of the times, because all of you know that your computer, like your processor, CPU and all that, they are built based on something called von Neumann architecture. All your processors are built based on von Neumann architecture. The CPU cannot read any data directly from the secondary storage and execute. CPU is designed so that it can only fetch instructions from the main memory. From the main memory only it can fetch the instructions. Fetch instruction, decode it and execute. Fetch the next instruction, decode, execute. So this is a continuous cycle that your CPU is always going to do that. So if you want to run any program, you cannot keep the program in the secondary storage and ask the CPU to run straight away. No. So first thing that you have to do is to load the program from the secondary storage into the main memory. And after loading the program into the main memory only, you can start executing the instructions. So your operating system also is available on the secondary storage. So CPU cannot directly execute that. That is why there is something called a boot process, and within the memory there is one memory called as read-only memory. This read-only memory and random access memory, like a CPU can access any part of it. CPU can access the data that is there or instructions that are there in the read-only memory also, because that is also main memory like thing on, except that the instructions that are written onto ROM, read-only memory, will not be erased even when you switch off the power system. So that's why the moment you switch on the computer system, it will first read the instructions from the read-only memory, BIOS you normally call it, basic input-output system, BIOS. So very primitive version of the operating system will be available in the BIOS actually. So that kind of primitive operating system will be there on the BIOS to such an extent that it will have the capacity to understand like how to read data from the secondary storage, what are the files that constitute the operating system that are to be loaded into the main memory. All such kind of knowledge will be there in the read-only memory. So that it is a two-step process. Initially, yes, it will fetch all the instructions from the fetch and execute the instructions from read-only memory to an extent where it identifies the files on the secondary storage, load all of them also into the main memory, and then slowly make all the system call services available by loading all of them into the main memory. So that way the new device driver related thing, they are all added to the operating system file that is there on the secondary storage. But those services cannot directly be immediately made available. So that's why after installation of the device driver, sometime they will ask you to restart. Because the moment you restart now, that file on the secondary storage is updated with the capabilities of the new device also. So that next time when you are booting up, it is going to load the new OS that is updated, which has got the capability to read and write on the new devices also. So this is how actually the overall operating system is actually designed, so that it becomes easy kind of thing. So now with this kind of understanding, you should be able to understand about how to write an operating system. Whenever you are asked to write or develop an operating system, you know now that Maybe you may have to develop certain main method, whatever main function. Apart from that, all these system call related functions you have to implement for every device and all that. And not only that, like how to manage the resources and all that, corresponding functions also, no doubt, slowly, one by one, you will have to do that. So any questions now, like up to this, clarity is there on device driver, operating system, system call, system program. These are all simple common sense words. So once you understand, there should not be any issue. Okay, so essentially operating system, that the Silver Stars book, Peterson or whatever, first 2 chapters, try to read with this background. So I'm not saying that whatever I'm saying only you have to write it. I'm just giving the bigger picture about what they are all and all that. You can read from any of the books as long as that is relevant and you have understood, and you can explain what you are actually writing. Will always be considered, no issue. But you need to understand. So whenever you are given a chance to explain what you are writing there in the exam or in the discussion, a kind of a viva or say whatever, as long as you are able to substantiate your argument, people will consider. But don't try to by heart just simply say in the book it is given, nobody will accept such kind of things. Okay. So that is one side of it. Today, let us actually write a small system program by using some of those system calls and all that, and write a program meant for that particular thing. Let us see that. For that, we can open a small terminal here. This is a prompt there, like where we are. So what is that we shall do? We will actually write a small program like CPU only, which is going to copy a file from one file to another file. CP syntax is going to be like this. So on my keyboard, C and some of the letters are not working, C and F. That's the problem. That's why I'm just using the online keyboard. See there? So it's saying CP missing file operand. CP minus minus help for more information. Okay, so this is the syntax of the usage of this. Usage, as you can see. CP and then options, these are optional as you can see. Anything that is put is in there. Minus T also is optional. Source and destination. CP followed by what is the source file name and destination file. What it will do? It will read the data from this particular file and copy that entire thing and write it into this particular file. But it also is a lot more powerful. Not only from one file to another file it can copy, but it can also copy, as you can see, CP followed by source 3 dots means any number of sources. So you can specify any number of files, file 1, file 2, file 3 and so on. At the end, if you give a directory, it will copy all these files with the same names. It's going to copy all of them into this particular directory. So the CP followed by minus T, directory, source, and all that. Copy source to destination or multiple sources to directory. This is what you really mean by it. Anyhow, so very small version of that. Let us actually develop. How it can be done? It is a C language. You require some background of C language to do that. To do that particular thing. So let me just use an editor. VI is an editor here. So my copy, right? I will call this as my CP kind of thing. A different name you are giving. My copy dot C. Again, dot C is this. Okay, let it be there as it is. Now insert. So in the case of C language, you try to include, right? As include stdio.h. Like this. And immediately let us actually develop the main function straight away. Main function signature can be int main of. We'll make use of the command line arguments. Just like in the Java language, you are using the command line argument. So here in C language also supports command line argument. Signature for main in C language for command line arguments is going to be, it is somewhat different. So first you have to specify how many command line arguments are there. So naturally it's going to be argument count. I'm just giving int AC. The first parameter is how many arguments are there. So how many means it is an integer. The second one is going to be the corresponding what you call the actual data itself, an array of words. An array of words. Just like in string args there in Java language, that you will have to specify. So that can be specified by using char. Char single pointer means like, or you can say here an array like this. An array of what? An array of words actually. So a word is a pointer to a character. So you'll have to specify star followed by AV, argument vector. Name can be anything. So you can specify, I'm just using argument vector AV like this. This is how you'll have to specify. So how many arguments are there, and the actual arguments list itself is going to be available. So initially we will only print all the arguments, and after that we will develop the actual logic and all that. So first it's going to be some index variable I. We will make use of index variable I. Semicolon. And then have a loop and display all the arguments. Display all the arguments within a loop. So you say for I equal to 0 semicolon, I less than argument count. Remember, it is an integer there, so you can directly use I less than AC. I is integer, AC also is integer. You can't compare an integer with a string. Many of you have done that while writing your Java program. You are just casually assigning a string to integer, comparing integer with string. All that is not possible. Only values of the same data types can be assigned to one another or can be compared and all that. Other places you will have to convert them. If you want to store a string of number into an integer, first you have to convert that string into a number and then only you can assign. Here you are saying AC is an integer, so no issue. I less than AC, I plus plus. And then curly brace begins. So we will just simply print to begin with, and after that we will extend our logic within this what you call argument 1. So percentage D, argument 1, 2, 3 is, what are the arguments here? Command line arguments, those are all the words or strings basically. So percentage yes. Then new line, you'll have to specify, comma. So first is, what is the argument? I is the number, ith argument. I is an integer. And then percentage yes. How is it available? In the form of argument vector. So AVR. AV is the name. AV of I. Ith argument. Like this, you can actually specify. So after doing all this, if you want to terminate your program in C language, one way is by using exit system call. Exit is again a system call here. Exit is a system call to terminate a process or terminate a program. Right? After this, curly brace closes. This is a small program. Still, we have not implemented copying and all that. We are only writing a small code that will work on command line arguments. Print, we have actually wrongly written. It should be print F, right? Oh. The problem is here, F is not this thing, right? Argument percent D is percent S, new line, I and AV of I. I is 0, I less than AC, I plus, all right. This is wonderful. So this is the situation. Okay. So now how are you going to do all that? By just simply compiling. You can compile by using GCC mycp.c. Expected semicolon, comma, or this thing before star token. Star AV. Character array. Char array, star AV. 25, semicolon, comma, or this thing, comma. Actually, like one more square bracket begin is going to do, or 2 double stars also will do. Okay, so let me signatures here. Two double stars will also do. Pointer to pointer or AV of all that line. So this is all right. We will have to specify here. So exit, because you are using exit now. Exit is a system call, you are trying to use it. And it's what you call, it's a prototype. We have only included stdio.h. stdio.h contains the prototype or signature of all your scanf, printf, that kind of thing. Whereas exit prototype is available in this particular library, in this particular header file, stdlib.h. So either we should not use exit, or if we want to use it, we should include this. That is the only small change that we have to actually do that. So let us all actually include it. stdlib. stdlib contains a signature of exit. That's why you are actually including. So these things will be there like this, small things. You must read and have thorough understanding, and whenever you are writing code, you should know what errors you are getting and what to do when such an error comes. Right? So when you are doing for the first time, maybe you go through this, and then strictly speaking, when you go through a particular book, you will understand all the details. Only thing is, you must have that reading habit and a kind of pattern. So once this is done now, it is a dot out actually. A dot out is the name of the executable file after compilation. A dot out, that is currently available on the current folder. /a dot out. Dot means in the current directory, a dot out is the file. As you can see, if you want to see what are all the files that are there, by giving ls, you will get them. But because there are so many files, so it is running on that, like, so there a dot out must have been gone by. Or if you want to just simply display all the files that are starting with a, so you can see a dot out is there, very much there as a part of it. So if you just simply say argument 0 is, as you can see, /a dot out. So whereas if you run like this, 1, 2, and then 3 and 4. Something like this. 5, 6 like this. When I give like this, as you can see, argument 0 is so and so, 1 is 1, 2 is 2, 3 is. If you keep anything within the double quotes, that entire thing becomes a single argument. Okay, so whenever spaces are there within the argument, you need to keep within the double quote like this. Then the whole thing becomes a single argument. Right? It is a system that's going to your shell that is actually running. This dollar prompt is displayed by a shell. There is one program that is running, and that fellow will help you to accept a command, load it, and run it. Split all these arguments also into separate things, and so a lot of thing is going to be done by your shell actually. So now our idea is ultimately you want to run this by saying a dot out and some file name, source file, source file name, and space destination file. Like this we want to give it. Right now it is only displaying whatever that you are giving, but now you have to open inside. You have to open the src file. You have to open the src file for reading purpose. You have to open the destination file for writing purpose. After that, keep reading the data from source and then keep writing that onto destination. At the end of the file, so you have to close both the source as well as destination. That is what a system program means. That is what a system program means. Probably with this background, like I want to just leave at this stage so that a kind of a question is left in your mind. You just prepare and then come for the next class about how to use system calls like open, read, write, close for copying a file from one file to another file. We'll complete this program in the next class, right? So by using this kind of command line arguments. So this is a small assignment to all of you. Go through that. If you have understood, you should be able to make small things. Okay? Is there any clarity on what is being asked? All of you are clear about? So this is a small assignment to all of you that you must know about how to use small system calls by using system calls related to open, read, write, and close. So go through the internet, make a study, and then come to the next class. Next week we will again meet on Wednesday, a continuation of this. So any other questions if you have, I can attend to. Otherwise we can close the session. As far as the recordings are concerned, still I have some internet problem. So once it is solved, I will upload all of them, most likely by today or tomorrow. I'm going to do that. So otherwise, let me just stop the recording.